Half-life. What is half-life? Half-life is the time taken for the concentration of a reactant to decrease to half of its initial value. The symbol for half-life is T1/2. For example, from concentration 2 molar becomes 1 molar, the time taken is called as half-life. Next example, from 100 molar to become half of it, that is 50 molar, the time taken is called as the first half-life. The next half-life, when 50 molar becomes 25 molar, is called as second half-life. And the next one is called as third half-life. How to derive half-life formula? Half-life formula can be derived from integrated rate equation. For zero order, the integrated rate equation is A0/A equals to KT. So, when you want to derive the half-life formula, we have to substitute value of A with A0/2. Since half-life is the time taken for the initial concentration to become half of its initial value. So now, let's substitute A with A0/2. And the T we substitute with 1/2, half-life. Then you will get A0/2 is equals to KT. And T or half-life is equals to A0/2K. So this is the half-life for zero order. The same goes for first order. We substitute we substitute A with A0/2 is equals to KT half. Then you will get ln A0 times 2/A0 is equals to KT half. A0 we can cancel off. Then we will get the half-life for first order is ln 2/K. Next, let's try for second order. 1/A0/2 minus 1/A0 equals to KT half. Then 2/A0 minus 1/A0 is equals to KT half. Then you will get 1/A0 is equals to KT half. So T half is equals to 1/KA0. So this is the half-life formula for zero order, first order or second order. Actually, you can just memorize the formula or you can derive the formula from integrated rate equation. What happened to the next half-life for zero order, first order and second order? For zero order, the next half-life becomes half of the first half-life. For example, the first half-life is 10 seconds. Next half-life is 5 seconds, while the third half-life becomes 2.5 seconds. All these values we can get from the formula. For first order reaction, we can see that value of half-life is constant. The reason is because half-life does not depend on concentration of A for the first order, while for the second order, value of half-life becomes double from the previous half-life. Next, let's try some examples. The decomposition of ethane to methyl radicals is a first-order reaction with a rate constant of 5.36 exponent -4 per second. Calculate the half-life of the reaction in minutes. So, since this one is a first order reaction, the formula for half-life is ln 2 over k. Just substitute the value of the rate constant, then you will get your answer firstly in unit seconds. But the question is asking for in unit time, so you just convert to time. Next example. This reaction follows second order and the rate constant is 7 exponent 9 per molar per second. Calculate the half-life of the reaction if the initial concentration of iodine is 0.06 molar. Since this one is second order reaction, so the formula for half-life is 1 over K concentration of I naught. Okay, remember that this one is not A, but the reactant is I, so that's why we cannot write 1 over K A naught. You substitute the value of the rate constant, then you will get the answer is 2.38 times 10 to the power of negative 9 second.